Welcome everybody, my name is Alan Keeler, and today we're going to talk about S3 and how it compares to some of the other motor oils that are out there, no-name brands to top brands, and then we're going to compare S3 to some of the more common oil additives that we can find on the shelves of our common auto parts store. So, if we look here, I'll show you how we're going to test. We have a lubricity tester. This is a 1/4 horsepower motor that, when turned on, turns this shaft here. We have a digital amp probe that shows that we're running about 4.0 amps unloaded. And when this thing is up and running, this is filled with an oil bath. This is an alloy dowel. It's a very soft metal as compared to this hardened Timken steel. And when we apply pressure with this torque wrench, eventually the pressure will be so great that it will overcome the lubricating abilities of the oil and the oil will fail. This is going to show us at what point this oil fails. Some of the oils that we have here, we have your generic off-the-shelf O'Reilly's motor oil. It's a 30 weight. We're using Mobil 1 fully synthetic oil, got a big name out there in the industry. Shell Rotella, which is very common for your diesel applications. And then some of the other more common additives that everybody seems to know about, Lucas, Marvel's Mist Oil, and Slick 50. And we're all going to compare those to S3. So, let's go ahead and get started. I'll turn this on. And we will start with the O'Reilly's 30 weight motor oil. There we can see we have plenty of oil built up. Let's zoom in on the wheel here. We have failure. Failure begins at about 10 pounds of pressure. We have full lockup at 25 pounds of pressure. Then we'll jump over to the amp probe. And we get up into some of the higher digits on the amps. In doing this, we can see that there's a pretty significant amount of metal that's been taken off of that alloy dowel pin. So what I'm going to do is take this, turn this alloy dowel a 1/4 turn, remove this oil bath, which is now full of metal shavings, the same thing that occurs when you have metal wear in your engine. Wipe and clean everything out. I'm going to use 80 grit sandpaper to make sure we remove all the remnants of the oil off. And now we will do the same process again. This time we're going to use Mobil 1. So, new bearing surface, new oil. We can probably just focus in here now on the torque wrench. We can hear about 5 pounds of pressure begins to fail. Right about 25 pounds of pressure. Again, the amp draw is going up to about 16. Again, we can look, we started out with a new metal surface. Here we can see a pretty significant amount of metal wear that's been removed. Take this bearing, turn it one more quarter turn. And we will try the Shell Rotella oil. As a comparison, this is just basically showing that it doesn't matter whether you get good oil, cheap oil, different type applications. Almost all automobile oils that we've tested have a failure point at around 20 to 25 pounds of pressure. This is the Shell Rotella. We'll come in here at the torque wrench. Again, 25 pounds of pressure. That one actually got up a little higher. $35 pounds of pressure. But again, quite a bit of significant metal wear taken out of there. Now, I will take this bearing that is now very hot. Now we will use the Mobile 1 with one of the more common additives out there, and that is Lucas. Wipe everything down. Grab a new dowel pin. Alright, so we've got everything wiped down. We'll grab our Shell Mobile, or our Mobile 1 full synthetic. Now we already saw that this one had a failure point of around 20 to 25. This is Lucas Heavy Duty Oil Stabilizer. Engine treatment keeps engines alive. Notice how thick this Lucas is. Lucas is like molasses. So we will begin. Let's come back up here to the torque wrench. There's not much help on the sound, about 10 pounds of pressure. $25 pounds of pressure on the failure. Not very impressive. So here we can see significant failure in the dowel. Now with that, we'll take this bearing out. And we will put in the Mobile 1 synthetic again. But this time we will add Slick 50, which everybody seems to know about as well. Alright, so new bearing surface. Start with the mobile one. Now we will add Slick 50 to the mix. Might sop up some of this oil that's here. We might have too much. We have a good amount of Slick 50 in here. And if we can zoom in on the torque wrench, we'll see what happens. None of these seem to be assisting the Mobile One oil. And again, pretty significant metal wear. Now we will take this, clean everything back up again, and add S3 to the mix. Okay, now that we've got everything wiped off and cleaned and put back to normal, we're going to put it all back together, and we are going to do our test of Mobile One with S3. So we'll grab a brand new dowel, put that in. We will add our Mobile One. Focus on the torque wrench and the amp probe together. Failure about 20, 25. Amps all the way to 6.4. Now let's focus in on the wheel. I want to show y'all how hot this thing can get. Begin to see the smoke coming off of that. That is an incredibly hot bearing. We can zoom in on the metal wear. I'll turn the bearing so we're able to see it. And with that kind of heat, it is really hot. Now, we're going to add the S3 into the mix. S3 is typically added at a 10% by volume ratio. And let's see how things perform. notice that this was about the time where the sound was impending the failure. We move up here, and this is where we had complete lubrication failure. If we're able to see the amp probe in the back, you'll notice that it hadn't even moved 1/10, just 1/10. And we'll go up to 35 pounds of pressure. You can see we've moved only 1/10 of an amp. The other thing that was significant was on the other test, I was applying pressure and letting off. Applying pressure and then letting off again. I've been significantly a lot longer period of time on this bearing, a lot more pressure. And I'll wipe it down so we can see that small little mark is the only damage that we're getting, showing how S3 enhances the oil's ability to lubricate and makes the whole system perform better. This is where we get the increases in horsepower by reducing the friction loss. Also, as you can hear, since the friction loss is down, the heat is down, and heat is a big killer to all systems. Now, the biggest killer to all systems, we've got a new bearing surface. I am going to remove the oil bath completely. Your car does not get worn out as you drive it from New York to San Francisco. And by the way, that is the contamination that's occurring from all that metal wear. But your car doesn't wear out driving from New York to San Francisco. It wears out when you drive home at night, turn your car off, and all that oil sits down in the crankcase. So you have a few seconds of dry start. When you fire it up in the morning, that metal-to-metal contact is what's really damaging that motor. This test is going to show how S3 penetrates the metal and gives us that few seconds of dry start protection. Here's where we were having the failure. Here's where we had complete failure. As you can see, the motor still thinks it's in an unloaded position. We can even go up a little bit higher. Now again, by now, with the Mobile 1, we had a significant groove cut in that metal surface. Now with this, I will take this surface that's on top that's dented, rotate this bearing so you can see. The other thing is, if you notice, I'm keeping my finger on here. It was so hot it was smoking before. Now it's not smoking at all. We're not even damaging the metal surface significantly. We've just mic'd the surface. Now, the one question that we do get quite a bit, we want to zoom out a little bit. I'm going to fill up a capful. The one question we get is, what is S3's failure point? So I am going to take a drop on my finger, put it on here, and now we will test it and see. We can zoom in where we have the amp probe and the torque wrench. You can also tell it doesn't matter if I go slow or if I go fast. The issue with this is this torque wrench only goes up to 75 pounds of pressure. We need to increase it and go to a larger torque wrench, which this one goes to double the size. Now this is normally a two-person project because all this weight I've got to hold the machine down, but we'll see if we can show it. So at 140 we slowed it down, but we didn't totally stop the machine. Showing all that weight, when we come over and look at the metal surface, again I'll rotate this bearing. There we are. We've just slightly marked the surface. Again, my finger is touching this. You can see how much cooler this bearing surface is. Thanks for watching. This concludes the test. One of the greatest things is to see this in person. If you have the ability to come down to our location here in Houston and see this live, we can use whatever oils you want, whatever you're currently using. If there's new additives that y'all want to see a comparison to, we're more than happy to do that. And if you have any questions or anything that we can do to help, please give us a call and let us know what we can do. Thank you.